Good afternoon, all of you. Thank you, Robert and Johan, for inviting me to this event. So, introduction about myself. My name is Gautham Ram. I work as assistant professor at Delft University of Technology. I'm in the group of DC systems, energy conversion and storage. We have 4 pillars: electric mobility, microgrids, power electronic conversion, and power electronics reliability. The group is headed by Power Bauer. And in this talk, I want to focus on 8 technology trends in vehicle-to-grid. Some of them have been already discussed before, but some of them are new, and we will try to see what are these emerging trends. The first trend I want to focus is vehicle-to-grid chargers have gotten extremely small. If you remember the previous days, if you went to a V2G project, there were chargers as big as me, and they would probably weigh 250 kgs, right? And suddenly, if you walk to this corridor, you see these really tiny chargers. If you saw the one from Volbox or you saw the one from Finema, you realize they've gotten small. So what has actually happened there? What has happened there is that in the past, we used low-frequency transformers, which were working at 50 hertz, and we are now moved towards high-frequency transformers. And we've also started using silicon carbide wide bandgap semiconductor devices, and we have started going towards soft switching topologies, which means our converters are much more compact and much more efficient than what we saw before. So which means we went from 10 kilowatt 260 kg chargers to 20 kilowatt 57 kg chargers. So they're smaller, lighter, and you don't need a crane, you can just walk up. Okay, not me, but a strong person, and put it up on a wall box, right? So that's a really big thing, because people want something small and compact in their homes, because in your home, you don't want big boxes of chargers or batteries, right? You want to use your space for something more useful. The second technology I want to focus on is the connection between solar and electric vehicles. I think the obvious reasons we all know, there's zero emissions. Those who like DC comics realize that both solar and PV, electric vehicle batteries are DC. But there are other innovative things which come in. We know that grid operators fear that with more and more electric vehicles and more solar, we have a congestion problem. But how about solving these two with using one as a solution for the other? And if you were to drive to your workplace with your car and you already have solar there, so which means there's a big plus in combining these two. So what did we do at Delft University of Technology together with our partners, PRE? So what we did there is we took a conventional solar inverter, and you have an EV charger where you convert the power from DC to AC and goes back. We realized, why do we convert this power to AC and convert it back? Because you need 2 inverters, and you lose power in this conversion. So what we did was we combined everything on DC, on direct current, and we just have one integrated charger for solar charging. And the benefit of this is that you have power from PV directly going on DC to the electric car. We just need one inverter instead of 2, one instead of having for solar and for EV. And with the bidirectional capability, you can automatically use your electric car as a storage for your solar. So all the benefits are kind of packed in one. So what this means is that your EV charger and your solar inverter are now in one system, which all possible power flows, like PV to EV, grid to EV, EV to grid, everything is possible with just one integrated solution. I think if you walk up, you see the solution of Finema, which kind of integrates this into a full charger. We're now making this next step with Heliox and PRE, and in that project, what we're doing is we are now also adding an extra battery to the system. You might ask, why an extra battery? If you want more flexibility in the built environment, and which means a car might be in some other place while your solar is still there, then the extra battery board gives you that benefit. And we want to put all of this electronics underground, because again, space is a luxury, and you want to use a space for your home or your built environment for more useful purpose. So you want to put all your electronics underground. So this is kind of an ongoing research project that we are doing. What is the next trend? We spoke about solar, but we have light here, and we have sono, and what they're doing is they're now putting the solar on top of the electric vehicle itself. So it opens up the new opportunity of combining solar with vehicle-to-grid. So when your car is parked, you charge your battery, and when you're connected again, you can then, while you're driving, you can then send this energy from the car back to the grid. So this combination of solar on board and vehicle to grid opens up very new opportunities that we didn't have before. And this is possible because we now got a vehicle to grid charger on board. And this opens up the debate, should the charger be on the vehicle or outside? So this, I think, is a very interesting trend, because there are a lot of trade-offs which I think we need to pay some attention to. When you put this DC charger outside, it doesn't have to be of automotive grade, which means it's much more cheaper than putting it inside the vehicle, which means the charger itself will be much cheaper to make when it's outside the vehicle. On the other hand, the car already comes with an onboard charger, which means it's cheaper for me as an owner to buy a car with onboard charger for the same price, if available, than a car which doesn't have a V2G charger, which means I don't have to invest another 5,000 or 10,000 euros for the V2G charger if it's already included. So which means you could even argue that an AC V2G charger is kind of coming for free if it's already included in the price of the car. So this is a little bit about the economics of how this will work out. And then if you have type 1 or type 2 plug already with ISO 50118, you can get a very good V2G proposition in the future if you are going for AC V2G. So this is an interesting decision that OEMs and infrastructure people have to make. And there's also the discussion I had with Bart earlier. What are cities going to do and what are countries going to do? They're probably going to go for AC chargers because it's cheaper. So how do these two technology trends come by? So I'm quite curious. We are working on both technologies to see how it moves forward. A related trend to this is the example that we have in Utrecht. I think Bart gave a nice example of how we have AC V2G, and I think we have more and more auto manufacturers trying to adopt this. The example of Hyundai Ioniq is also there. If you go towards the next trend, if you now look at vehicle to grid, there's a different technology, and that's vehicle to load. And what is vehicle to load? Vehicle to load means that I can take my car, I can put a plug, and I can have a coffee in the middle of nowhere. Or, if any of you ever wanted to go onto the street, sit next to your electric car and play a computer game, I don't know how many of you want to do that, you could do that with this particular option. But more useful applications are, for example, powering your campsite. I think it's very interesting. A lot of people in the US want to go to a national park and they want to power their campsite with vehicle to load. So these opportunities are opened up by having standalone operation of the electric car. And I think after aircon, I want to introduce a new word. It's called V2F, vehicle to festival, right? Because it's another new application. And another type of load can also be an electric vehicle itself. So which means you can do vehicle to vehicle. I've not yet tested this, but one of the propositions from Sono was you can then run this vehicle to load, but the load is now another vehicle, and you can do vehicle to vehicle. So I think we can go from A to Z, and we can always think of some application for each of those letters. But I really believe V2V or vehicle to load are very interesting propositions that we don't yet focus on, but it's going to come more and more moving forward. The next trend, which is very interesting, it's just not an idea, just an idea, is from the Ford 150 pickup truck. So what they propose there is that you can use a pickup truck along with a Delta converter and a Ford charge system, and you can actually power your home standalone. So which means looking at much higher power levels, and in this case, the proposed power level is 9.6 kilowatts, which means you can completely power your home in the middle of nowhere. And this is a very useful value proposition because there are large parts of the world, I'm not talking about the Netherlands, where the grid is non-existent or is unreliable, and you still want to electrify your vehicle fleet. So in those kinds of situations, such an application will be extremely useful. So for example, at TU Delft, we now start a project similar to the scale project in the TAME 2.0 scheme called V2X. And there what we want to do is we want to integrate PV, stationary storage, and electric vehicle and AC grid for standalone applications for vehicle to load and grid connected applications. So it's like a UPS system when there's no grid, but it's just a conventional V2G system when the grid is available. So it combines these functionalities, and you would be surprised, so many people have emailed us after our previous solar project saying, I have this house, it doesn't have a grid connection, and I want to power it with solar and my car. How do I do it with your charger? So there's a clear demand for such a system, and we can facilitate it using this particular technology. The last two trends. So what you see here is not science fiction. If you jump into any Tesla car today, it has the ability to a large extent propel itself and make decisions on how to navigate. So which means what we will have in the future is the ability to use our electric car as a true battery on wheels, which means that it should be able to navigate itself and be able to move energy. We all know that the most expensive component in public transport is the driver. And the moment you remove the driver out of the loop, you open up so many different opportunities with autonomous driving. So in this case, we can facilitate this. And we also now have a project, a national project, on looking at how we can use electric car batteries as a means of energy transport in terms of flexible energy communities. And the interesting thing there is we work with Wageningen and Groningen, which means we not just look at the technical perspective, we bring in the legal, the economic, and social perspectives together, and I think that's the way forward in order to quickly realize these technologies in short time. And the last trend is about battery degradation. Does anybody have a strong opinion? It's good or bad? It's good. It's good for the battery degradation. My honest answer is I don't know. The reason being is on one side, vehicle to grid increases the number of cycles on the battery, so it must age faster. But on the other hand, we also know from calendar aging that lower state of charges are actually better for calendar aging because it lowers the calendar aging. So if you can do vehicle to grid intelligently, to bring to average lower state of charges from a calendar aging perspective and from a cyclic aging perspective, optimize the number of cycles, we could be in a kind of a sweet spot. So I think in our new V2X European project, we want to investigate this much more deeply to see how bad is it and what can we do about it. And one point to recognize is we have million-mile batteries coming up. And if you look at the data from the Tesla User Forum, which is maintained by the Tesla User Forum, but also you can see it from Martin Steinbuch's website, the degradation is not that bad. If you extrapolate this data, this car battery will last 800,000 kilometers, and it only has lost 20%. So which means maybe it is an issue, but maybe it's not too much of an issue because the car battery is anyway going to last long. Okay? Thank you so much for your time. If you want to learn more, we have a massive open online course on electric cars. We've had nearly 200,000 learners who have followed our course. So the course is for free, and you can listen to more lectures from me, but I'll probably be a little bit slower than what I am today. Thank you for your time.
Lecture online. Thank you, Gautham.